Today's lesson has to do with trigonometric ratios of right triangles. This lesson works only for right triangles, so just keep that in mind. I'm going to draw a triangle down here. I'd like for you to copy this down in your notes. Here's my right triangle, and I'm going to call it triangle A, B, C. And I'm going to call this angle here theta. Okay, theta. Alright, and then this side opposite of angle A, I'm going to call little a. And the side opposite of B is going to be little b. And the side opposite of C is going to be little c. Those are the sides. A hypotenuse is going to be the longest side of the triangle. So this is the hypotenuse. I'm going to abbreviate. Okay. The legs are the other two sides. The side adjacent to the angle is one of the legs, and the side adjacent here, adjacent means next to, is right there. So the side adjacent is B. The side opposite of the angle theta is going to be angle A. Okay, so the hypotenuse in this picture is C, and then the side adjacent, which means next to, is B, and opposite is A. Alright, well, let's look at our ratio here. Sine is opposite over hypotenuse. Cosine is side adjacent over hypotenuse. And tangent is side opposite over adjacent. So looking at this triangle that we have drawn, sine of theta is opposite over hypotenuse. So opposite is A, little a, and hypotenuse is C. If I look at cosine here, cosine is adjacent. Adjacent is next to the angle theta, and hypotenuse is still C. Then we look at the tangent. Tangent is side opposite, which is your A, and your adjacent is B. So this would be for this triangle here. Let's look at this acronym that we use to remember. This is called SOHCAHTOA. So is sine, opposite over hypotenuse. CA is cosine, which is adjacent over hypotenuse. And then TOA is tangent, opposite over adjacent. So this is a good way of remembering SOHCAHTOA, remembering our trig functions and their ratios. Let's look at the first example. This example is found in your book. There's a triangle. We've turned it a little bit this time. And this is A, B, C. And this side is 18 meters. And the hypotenuse here looks like it's 33 meters. Let's look at what this example says. It says to find the sine, cosine, and tangent of angle B. Well, here is angle B. So I'm going to go ahead and write down what I need to find: the sine of B. I need to find the cosine of B. And I need to find the tangent of B. Tangent of B. So that's what I'm looking for. Okay, let's look at our picture here. It says B is our angle right there, and opposite of B is 18, and the hypotenuse is 33. If it will reduce, you need to reduce it. Okay, cosine of B is adjacent. Now wait a minute. I don't know what the adjacent is, so I am going to have to find what BD is, because I don't, actually it's not BD, it's BC. I need to find out what BC is. What strategy would we use to find a missing side of a right triangle? Well, we need to use a Pythagorean theorem here to find the missing side. Pythagorean theorem is a squared plus b squared equals c squared, and I need to find the missing side. I know a leg, which is 18. I don't know the other leg, and I know the hypotenuse is 33. So now I need to find the b squared. I need to solve for b squared. When I solve for b squared, I'm going to get 18 squared, and then I'm going to need to subtract it over to the other side. And when I do that, I'm going to get b squared is equal to 765. The next thing I need to do is to take the square root so that I can find that missing side. When I take the square root, it is not a perfect square. So I will need to do the factor tree or factor ladder to find what the factors are and get that simplified down. So over here, I'm kind of running out of room. I'm going to start up here, 765. I'm going to do the factor tree. 5 will go into it, I can tell right off the bat, and gives me 153. And then I can divide it again. 3 will go into that, which will be 5 and 151. Okay, that's actually still divisible by 3. 51 divided by 3 is 17. So I have 5, 3, 3, and 17 are my factors. The 3 and the 3 are couples. They come out of the rad, leaving the rest under the rad. So this side over here is going to be 3 rad 85. Sorry, 85. And where I got that from was when I took the square root of 765. It comes out to 3 rad 85. And this needs to be simplified like that. Okay, so when I'm finding cosine, back to finding cosine, cosine is adjacent. Okay, I now know adjacent is 3 rad 85, and the hypotenuse is still 33. Now this will reduce, if you look at it closely, it will reduce. 3 and 33 will cancel each other out, leaving 11. So I have rad 85 over 11. Be sure and circle your answers on your homework. Makes it easy to grade in all this mess. And then tangent of B is going to be from B. Remember, tangent is opposite over adjacent. So that's 30. Opposite is 18 over adjacent, which is 3 rad 85. Now you need to remember that rads in the denominator is a bad thing, bad news, and we need to get rid of that. So we are going to get rid of the rad, and we're going to do rad 85 over rad 85 to get rid of the rad. Alright, when I multiply that, I'm going to get 18 over rad 85 all over 3 times 85, because a rad and a rad get rid of the rad, and so 3 times 85 before I go to all the trouble of canceling, I could have canceled here, which would have left me with a 6, and then that would be 6 over 85. And that won't reduce. So 6 rad 85 over 85. So that would be the best way to do that one. Let me circle my answer. And I'm sorry for the mess here. It's a little bit messy. I need to try to erase it as I go, I guess. All right, thank you. Let's go on to the next page. So we can't have rads in the denominator. All right, next page we have the reciprocal of these trig functions. And the reciprocal for sine is cosecant. Okay, and that's spelled C-O-S-E-C-A-N-T, cosecant of theta is the reciprocal of sine, and so it's going to be hypotenuse over opposite. So sine was opposite over hypotenuse, so it's the flip of that, the reciprocal. Then we have secant here. Which is the reciprocal of cosine. And then we have cotangent. Okay, cotangent is going to be the adjacent over opposite. Let's look at the first example here. It shows cosine of theta is 3/4, and secant of theta is what we're looking for. Well, secant is the flip of, is the reciprocal of cosine. So secant here is the flip of cosine. So all I have to do is do 1 over cosine. So secant is of theta is 1 over cosine, that's above, and so all I need to do is take cosine and flip it, and I will get secant. So my answer here is that secant of theta is 4/3. I just flipped that. You could write 1 over 3/4, where this is the main fraction line, but then you're going to flip. All right, the next example I want you to do on your own, and we'll check that tomorrow. All right, next page. All right, now we're going to do where we have to find all 6 of the trig ratios for a triangle. So we have to find all 6 of them. Okay, here's your picture, and actually I'm going to write it up here so maybe it won't get so busy. And this is going to be NMP is our triangle. Here's our right triangle. This is 10, and this is 7. Okay, notice we're missing a side. We're going to need to know that side to be able to solve these problems. So we're going to have to figure out what that side is. We're going to find the sine of P. But before we find the sine of P, we need to find what that missing side is. We're going to use Pythagorean theorem. So 10 squared plus 7 squared equals, I don't know what that side is squared. I'm going to call it Pn squared. So I'm going to use Pythagorean theorem to find that missing side. So 100 plus 49 equals Pn squared. And that's 149. Take the square root of that if you notice that's not a perfect square. So we're going to have to do the factor tree. And if you do the factor tree, you're going to find that it doesn't factor down anymore. So that's the best we can do with that one, is just leave it as rad 149. Okay, so we need to find the sine of P. So here is our angle P that we're focused on, and P, sine is opposite over hypotenuse, so opposite is going to be 7, and the hypotenuse is rad 149. Now, if you remember, we can't have rads in the denominator, so we're going to have to get rid of the rad, and in order to do that, we have to do rad 49 over rad 49. And that leaves me with 7 rad 49 over 149. If 7 went into 149, we could reduce that, but it doesn't. And so that is our answer here. 7 rad 149 over 49. Okay, let's keep going with this. We have cosine of p, which is adjacent over hypotenuse, is our SOHCAHTOA. Adjacent is 10, and hypotenuse is 1 rad 149 under a rad. We can't have a rad, so we have to multiply by rad. 149 over 149 to get rid of that radical. And that leaves me with 10, 149 over 149. And even though that's a crazy answer, that's our answer. We can't do anything to reduce that. Okay? And we're really going to run out of room here. On your paper, you're going to have enough room, but when I write this on this iPad, I'm not having enough room. So I want to do tangent of P. Tangent is opposite over adjacent. So opposite of P is 7, and adjacent is 10, and that doesn't reduce, and that's that. Now we need to go and find the other three. Okay, I'm run out of room, so I am going to erase some of this. I'm going to leave these answers here because I can use them as a shortcut. Okay, so I'm going to leave, this was sine of P. And this is cosine of P. Okay, so we're going to find the other three. And since we've already done all of those, the other three should come in really handy. It should be really easy. Okay. The other three I need to find is cosecant, and that is the reciprocal of sine. So all I have to do is flip sine. My answer for sine, I just need to flip. (149) over 7 rad 149. Now here's my dilemma. This is a radical in the denominator. And so I have to get rid of that. Now, one of the things that I like to do, and because I didn't leave enough room here, is to go back and look at it before I got rid of the rad in the denominator and then flip it. So, so we probably need to go and do that. Okay, well, before I flipped sine, or before I got rid of the rad, it was 7 rad 149. So I'm going to take my 7 rad 149 and I'm going to flip it. And so that's going to give me 149 over 7. It's better to go back before you got rid of the rad, just because you get rid of it and put it on top, and then when you flip it, it's back on the bottom, and you're back to having to get rid of it again. So it's better to go back. Okay, so I'm going to take this and I'm going to simplify it, and it doesn't simplify because 149 doesn't simplify. So that is your answer. Okay, all right, the other one I need to find is secant. Secant is the reciprocal of cosine, so I'm looking over here at cosine of P. Now let's go back to cosine before we flipped it. And cosine before we flipped it was 10 rad 149. So if I flip that, I'm going to get rad 149 over 10. And that will not reduce. And then the last one, I'm going to put it over here, is cotangent. Cotangent is tangent was 7/10, and so cotangent is going to be the flip of that, which is 10 over 7. So those are your answers. On your paper, it would really help if you write them in order, sine, cosine, tangent, and then cosecant, secant, and cotangent will help in grading that. Okay, we just have a little bit more to go. We've got our special right triangles. We learned these when we were in geometry, and these have to be memorized, and you will take a quiz over this very soon, so be prepared to take a quiz. Your special right triangles, your first one we're going to learn about is the 30, 60, 90. And this should be a review, but we're going to review them. Okay, there's a triangle, and I'm going to call this side right here, this shorter side over here. I'm just going to call this one 30 anyway, and this one 60. Opposite of the 30 is your shorter side, which is 1. Opposite of the 60 is rad 3. And opposite of the 90 is 2. And we need to have this memorized. Not so much for this lesson, but for the next lesson. So go ahead and begin memorizing your special right triangles. Okay, your 45, 45, 90, the legs are the same length. And we call them 1 and 1. And this one is, the hypotenuse is rad 2. And again, you need to have these memorized. These are derived from the Pythagorean theorem. You could use the Pythagorean theorem to test and make sure that these work. Okay? All right, the last thing that you need to do is you need to look in your book on page 285. Well, this just moved. 285. And it's actually 87. Okay, and 287 gives us a table, and it goes through all the trig functions, and there's just a pattern formed in this, and the pattern is the cofunctions. If you look at, on the table, if you look at sine of 30 degrees, and this is moving, I don't think this page is not still. Okay, the sine of 30 degrees is the same thing as the cosine of 60. Okay, and if you look at the cosine of 30 on the table, so you look at the table in your book and you look at cosine of 30 degrees, and it's the same thing as sine of 60. And because of this pattern, they have established these cofunctions. We won't use, I think there's only one example of these cofunctions on your assignment, but these are the cofunctions. We'll write them down. The sine of theta is equal to cosine of 90 minus theta. So no matter what I put in there, it doesn't even have to be 30. If I put in the sine of 15 degrees, is equal to the cosine of 90 minus 15, which is 75 degrees. So the sine of 15 degrees is the same thing as cosine of 75 degrees. And this works for all of the functions. Let's do cosine. Cosine of theta is equal to the sine of 90 minus theta. The cotangent, actually I need to do tangent. The tangent of theta is equal to the cotangent of 90 minus theta. Secant of theta is equal to the cosecant of 90 minus theta. Okay, I've run out of room, and I know y'all probably have more room on your paper, but we still have 2 more to do. We have cosecant of theta is secant 90 minus theta, and cotangent is tangent 90 minus theta. That is found in your book on page 285, or 87, I'm sorry, and you can write those down. All right, that is all that you need to do. You have a few examples on your flip practice just to make sure that you understand it, and y'all have a good evening.